In this video, we'll review the concepts of naming in organic chemistry. So I'm looking at the first structure, and the first thing that I'm going to do is identify the parent chain and number the parent chain. So I'm going to start with the aldehyde functional group. Of course, it's always going to be on the end, so that'll be carbon number 1, 2, 3, 4, 5, 6, 7. Now, it is worth noting that we do have two functional groups because we also have the amine or the amino functional group, but the amine is less important, so it will be considered to be as a substituent in this particular structure. An aldehyde is always at the end of an organic molecule. Therefore, we do not need to say that it's on carbon number 1, but we'll need to use the suffix al to indicate that it's present. It's a 7-carbon chain, so actually I'm going to start with that. So I've got hept. I do have a double bond on carbon number 5, so it'll be dash 5 dash ene. And then we have, of course, the al, which corresponds to our aldehyde functional group. Now we have one substituent here, and that's the amino substituent, but it too has a substituent, and that's the isopropyl group. And we'll need to say that that isopropyl group is on the nitrogen. So we'll write something like the following: 3-amino N-isopropyl. Now, of course, it's always tricky when I start with the parent chain first in order to be able to fit all the substituents in, and sometimes you'll need to erase or move things around. So far we have 4 parts of the name. So we have the functional group, we have whether or not there's any unsaturation, we have the parent chain, and we have the substituents. The other components, the 5th component, is the stereochemistry. And we have, of course, the EZ type of diastereomer. And in this case, essentially, it might be helpful to put in the hydrogens. And the idea is that we start with one of the carbons and we prioritize. And let me just change my pen color here. We prioritize about that carbon number 6. And we have a higher priority on the right-hand side because that carbon, of course, beats the hydrogen. On our next carbon right here, carbon number 5, we have a higher priority again on the right-hand side. So the two 1s are on the same side. Therefore, this is a Z. We also have a chirocarbon on carbon number 3. So I'm going to prioritize in this case. I'm going to use a green pen. So the nitrogen has the highest priority. And then looking out from carbon number 3, we have carbons 2 and 4, and they would have the same priority. Going forward, we have carbons 1 and 5. Both of them involve a carbon double bond something, but carbon number 1 is double bonded to an oxygen, which would beat, of course, another carbon. Therefore, my next highest priority is over here, and then 3 on the left-hand side, and I also have a hydrogen on this structure. Now, we want the hydrogen going away from us, which would be, of course, this priority number 4. And so I'm going to simply switch the priority groups. So take that 4 and make it a 1, take the 1 and make it a 4. Now I'm going to count 1, 2, 3. And when I'm counting, I'm going counterclockwise, but that's after the switch. Therefore, the original must have been clockwise, or R. So once again, I counted 1, 2, 3, which is counterclockwise, but that was after the switch. So the original must have been clockwise and therefore R. Now I need to bring these into the name. Now usually in an exam situation, you're not going to have 2 stereochemistry events, but it's not difficult to include both. Now I'm going to write 3R, although I could have just written R because it's the only chirocarbon, and I have 5Z. Now the idea for the stereochemistry is you list these guys in chronological order. So the R comes before the Z, in terms of 3 comes before the 5. So there is the complete name with the 5 components of an organic structure. Now let's move to the ring structure, and I'm going to go back to my red pen. Now in this ring structure, the most important thing, the one with the highest priority, is my functional group. So that'll be carbon number 1. The next most important thing are the double bonds. And so I'm going to number, in this case, in a clockwise way. 1, 2, 3, 4, 5, 6. Now I want to name this compound, given that I realize that we have the alcohol functional group. So the suffix is going to be OL. We have a cyclohex because we have a 6-carbon chain, and we have 2 double bonds on carbons number 2 and on carbon number 4. So it's going to be hexa. That A is just for good sounding. And then I want to say 2, 4, diene, and then the alcohol group. Now, if an alcohol group is on a chain, we need to say where it is. But given it's the most important thing in this ring, it's just diene-all. I don't need to say 1-all. In fact, that would be incorrect. We do have the substituent. It's on carbon number 6. Note, it's not on carbon number 2 because, of course, double bonds have a higher priority. So this would be therefore 6-chloro cyclohexa 2,4-diene-all. I hope you have found this quick review helpful in thinking about nomenclature in organic chemistry.